All right, good evening, everyone. Please, if you're active, if you're online, indicate that you're online. If you're online, indicate that you're online. We are about starting now. Please indicate that you are online. Please indicate that you're online. We are about starting now. I hope the board is very visible. Please indicate that you are active, that you are online. All right, good evening, everyone. Okay, we shall start in a few minutes. Please do me a favor to share the link to your various platforms. Share the link to your classmates. Share the links. Let's invite more people to join this live class. Let's invite more people. Please do me a favor. Share the link. Share the link. Share the link. All right. We have just 2 minutes to do that. We have 2 minutes to do that. Please, if you have shared the link, indicate that you have shared the link. If you have shared the link, indicates that you have shared the link. Please indicate that you have shared the link. Please, if you have shared the link. All right, so let's start. We shall be looking at turning point of a curve in Math 102. In some university, they call this is under Math 104. Instead of Math 102, I think those in UNN, they call it Math 104. Why those in IMSU 102? But they're all the same course content. All right. Now, in our previous class, we talked about differentiation. In fact, we started by talking about calculus, that it is grouped into two. We have what we call differentiation, which is finding the derivative of a function. All right. Then we also say we have what we call integration. And we mentioned that if we have a given function, let's say y equals to fx, all right, we can be asked to find the derivative of this function with respect to a given variable, or maybe y with respect to x, s with respect to y, all right? And we said that to find the derivative, we said we use a symbol dy dx, or y prime, or f prime of x. Okay, this is simply the symbol used in finding the derivative of a given function. The symbol used in finding the derivative, all right, of a given function. Then we also talked about higher derivative. When you hear the word higher derivative, we are talking about second derivative functions, third derivative function, even fourth or fifth derivative function. The first differentiation or the first derivative is called the first derivative of a function. For example, if I have y equals to f of x, and I'm to differentiate this, the symbol is dy ds. So after differentiating y with respect to x, the first derivative is called first derivative function. You might be asked to find a second derivative function, meaning I have to further differentiate the first, all right, to get the second. To find the second derivative function, it means I have to differentiate this, which is the 2y over the s squared. All right. This is also can be represented as y prime prime or f prime prime of what? Of x. This is called the second derivative function. This is called the first. This is called what? The second. We can also have the third, which is the 3y over the s cube, or y prime prime prime, or f prime 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 of what? Of x. This is called the third derivative function. Why this is necessary? Because I'll be using this to explain the turning point of a curve. At what point can we say a curve turns? At what point can we say a curve has a minimum turning point, a maximum turning point, or a point of inflection? All right. So I'll be using both the first, second, and sometimes the third to verify the point of inflection. All right. So let me take it one after the other. I want us to just take note that differentiation, okay, can be of higher derivatives. We can have what we call the first, second, and third. And what I mean by that is, let's say if I have y equals to x to the power of 3, and we are asked to find the y dx, number 2, the 2y, the s squared, number 3, the 3y, the s cube. Already we have learned how to find differentiation or derivative using various methods. We say we have the power rule of differentiation, also called the general method of differentiation. We have the first principle, we have the product rule, we have the quotient rule, we have what we call the implicit function, we have what we call the chain rule or function of a function. All of these I've discussed in my previous video. Okay, so if we are given this, I'm going to use what we call the general rule or the power rule to differentiate. Don't forget the general rule that says that if we are given a function y equals to ax to the power of n, the rule says we multiply the power with the coefficient of x and subtract 1 from the power, meaning that they become our dy dx equals to an, or I can say n times a is nax, right? N times a is na. Then we have x. The rule says subtract 1, n minus 1. This is what we call the first derivative function. This is called the first derivative function, also called the power rule of differentiation. So it means that to apply the first derivative function to find the y dx, this means first derivative. Don't forget, I have to apply the power rule of differentiation, and that will give us what? Let's verify what the result will be. Let's verify. This will give us the coefficient of this x here is 1. So I'll multiply 3 by 1. That will give us 3x. The rule says when you multiply, we subtract the power by 1. So 3 minus 1 will give us what? It will give us 2. This is called the first derivative function. Then to find the second derivative function, which is the 2y ds squared, what do we do here? I will further differentiate this. All right. So here we have 2 times 3 will give us what? 6x. Then we'll subtract 1 from this power. That will give us 1. We can just say 6x, knowing that the power of this x is what? Is 1. Then the third derivative function means I will further again differentiate 6x, and that will give us 6. If I'm to find the fourth derivative function, it means the answer is 0, right? Because whenever we differentiate a constant value, it always results to 0. Okay, so this is just a recall of what we discussed in our previous class on how to differentiate using the power rule of differentiation, of which I'll be employing to explain turning points of a curve. Now let's look at this topic in detail. Please, if you are following, please indicate in the comment section. Let's know those who are following, and ensure you share the link to your classmates. Please ensure. Please, if you are following, indicate. If you are following, please indicate in the comment section. Please just join us. Ensure you go back to start from the beginning. Don't just join the class. You might not get what we are saying. Please. All right, so let's look at the word turning point of a curve. In mathematics, we have different kinds of curve. Okay, depending on the kind of functions. We have different functions that have their various curves, right? We have what we call the linear function. I hope you're aware. The linear function. The general form of this function is y equals to ms plus c. All right, so a graph of y against x will always give us a straight line graph of this kind, right? This is also a curve, but it's a linear curve. Are you there? This kind of curve is always, either it's increasing or decreasing with respect to a change in x. As is increasing, s is also increasing. As y is increasing, right? S is also what increasing. All right. So it can also happen as y is decreasing, s can also what decrease. So any graph that gives you a straight line is a linear graph, also called a linear curve. All right. When you visualize the word curve does not always mean it must have to be a quadratic or a cubic or anything. The word curve can be a linear curve. A linear curve simply means a straight line graph. That's what it means. So this is a linear graph. All right. The general form is y equals to ms plus c. Now we have what we call the quadratic. The quadratic function. And we have two ways of representing a quadratic function. The first is y equals to as squared plus bs plus c. When you plot a graph of y against x, you're going to obtain a graph of this kind. A graph of this kind. What do you notice here? This graph opens upward. It opens upward. It is concave upward in the sense that it opens upward. Any graph of this kind will always open upward. If you look at this here, the coefficient of s squared is positive a. Whenever the value of your a is greater than 0, the graph must have to open upward. It is a quadratic graph, also called a parabolic graph. And that word for this is parabolic. Please take note. A parabolic what? Graph. A parabolic graph. So whenever a is greater than 0, meaning that the value of a is positive, right? Any number greater than 0 must be positive values, meaning from 1, 2, 3, 4, 5. So the general form of this kind of function must be the curve we have to open upward. But what happens if I have a curve like this, minus as squared plus bs plus c? In this case, this curve will open downward. This curve will open downward. In this case, a is less than 0, meaning that the value of a is less than 0. And number less than 0, we have minus 1, minus 2, minus 3, minus 4. So anytime you have a graph like this, positive, you have a function like this, rather, you must have a graph, a curve that opens upward. We have a function like this, whereby the coefficient of s squared is negative, the graph must open downward. Now, we have a third graph, which I'll be talking about, which is a cubic function. A cubic function is a function of this kind, y equals to as cubed plus bs squared plus cs plus d. This graph is more like a combination of these two graphs that forms a S kind of shape, a S shape. It can be of this kind. I can have it this way and have it was this way. What you notice is that we form a S shape. This is called a cubic graph. Now, there's one thing I want us to take note of in quadratic function and cubic function is that in the quadratic function of this kind, we have a pointer called the minimum point, the lowest point in the graph. All right, in this graph is called the minimum point. The highest point in this graph is called the maximum point. So whenever a curve is opened upward, the curve have a minimum point. When the curve opens downward, the curve has a maximum point. But when the two curves are joined together to form an S shape, we can have what called maximum, minimum, and a third point called the point of inflection. The point of inflection. Inflection. Or we can also write it as inflection. S-I-O-N. Okay, I have this point here is called the maximum, don't forget. This point is called what? The minimum. Then this point here, the point where the curve changes curvature, where the curve rather changes its shape, its curvature from maximum. At this point, the curve changes as if it's changing the direction, all right? It's called the point of what? Inflection. Yeah, I have the maximum point, I have the minimum point, I have the point of what? Inflection. All right, so let's look at this now. I want us to understand these major functions. We have other functions like the sine, the trig functions. Under the trig functions, trigonometry functions, we have the trigonometry function. Under the, we have our sine function, like sine x, we have cos x, we have tan x. All of these are under, we have exponential x, right? We have logarithm functions and the rest. But the major functions I want us to focus on, majorly in this turning point of a curve, is linear functions, quadratic functions, and cubic function. And we'll be solving so many problems as we continue. Okay, I hope you guys are following. Please, if you are following, indicate in the comment section. If you are following, indicate in the comment section. Now, what exactly is turning point of a curve? When you do a word turning point, by the word turning means a point. Turning point means a point where the curve tends to change direction, either from increasing or decreasing. That's called a turning point. Then of a curve, let me illustrate, let me give you an instance. If I have a graph of this kind, what do you notice here? At this point A, I have a point here, I have a point B, and I have a point C. At point A, the graph is increasing, right? The graph gets to a point here, whereby it changes what? Direction. It increase and decrease. That point where the graph changes direction, or where the curve changes direction, is called the turning point of what? Of a curve. All right. We also see the turning point of a curve as the point where the tangent line is horizontal towards to that curve, meaning that the slope of the tangent line is equal to 0. A tangent line is a line that meets a curve at a particular time, at a particular point rather, and that tangent line determines the slope of what? Of that curve. Let me explain, for example. Now, I'm bringing up a concept now called the tangent, right? Tangent line. In my previous class, for those that attended my physical class, we talked about the tangent line and the normal line. If I have a curve that curves this way, and let me say I have my Cartesian diagram, and I'm to find the slope of this curve at a particular point, let's say x equals to 1. What do? I will need to trace along the x-axis, right? Let's say if I have here as 1, right? Let's say find slope at x equals to 1. What do we do here? I would locate my 1 on the x-axis, right? Then trace it downward. That point where the number 1 touches the curve, I will draw what? A line here. Just a straight line that passes through what? That point. That straight line that passes through that point is called what? The tangent what? Line. The tangent line. This straight line you're seeing here, let's say I have point A, I have point B. The straight line that touches a curve at a particular point that determines the slope of that curve is called what? Somebody? The tangent line. I hear there somebody. Now, when you hear the word turning point of a curve, if I have my tangent line somewhere here, okay, definitely, whenever your tangent line is horizontal, the slope is equal to 0. If I have if I have a tangent line that cuts a graph at a particular point of this kind, it means that I can determine the slope, right, of what? Of that line. And the slope of this line gives the slope of what? Of the curve at that point. S equals to 1. Am I communicating now? If I'm to change my position, let's say to 2, I'll have a different slope. So sometimes in the exam, for those of you that did graphing in secondary school, let's say after plotting your quadratic graph, they will tell you to find the slope of the graph at s equals to a particular number. Let's say s equals to 1 or 2. If you are good in further mathematics, what we do then in those days in secondary school is that I will just plot because there's no time. We have limited time. I will just construct my graph, draw my target line at that point I'm looking at. Then I will use differentiation to get my slope. What do we do? What will I do? Let's say, for example, now, let me give an instance. Let's say I have a function like this, s squared plus 4x plus 5, y equals to this. And after plotting my graph of this function, let's say I obtain a graph like this. I mean, this is the kind of graph you will obtain when you plot a graph of y against what? X. Are you there, somebody? Then the examiner will now ask you, say, find the slope of this function at a particular point. They will always give you a point. They will tell you at x equals to what? 1, for instance. So what do you do? For someone who did further mathematics or someone that knows calculus, what do you do? Because you are trying to minimize time, what do we do here? I have to construct my graph. Then draw a tangent line meeting that point of interest. The way you draw it, this part here becomes my change in y, right? It becomes my change in x. Don't forget, I will look for the change in y along the y-axis and change in s along the s-axis. Then I will say slope equals to what? Change in y over change in x. Most of the time, we don't have enough time to start doing this. To start looking for y2 minus y1 over s2 minus what? S1. What do we do most of the time is just to differentiate this. Once you differentiate this, that will give you the slope of that curve. Meaning, here becomes the y, the what? The x equals to what? Using power rule, here we have 2x plus 4, right? Then at s equals to 1, it means my dy, the x, equals to 2 times 1 plus 4, which is equals to what? 6. It means that approximately you are expected to have something close to 6 when you find the slope of that curve at that particular point of interest. Are you there, somebody? That is just it. So whenever we have a curve, okay, we can determine the slope of that curve by taking note of the point of interest. Then the point of interest will tell us where the tangent line we have to pass through. The slope of this tangent line you are seeing at this point is equals to the slope of that curve, of this curve at that same point. That is how to find the slope of a quadratic curve. But whenever this tangent line is not like slanted, it's not in a slant form like this. You know, in this case, it's a slant. It means I can find my slope. Whenever I have a slant line, a slant tangent line, it means I can find my slope at a particular point. But when this tangent line is now horizontal, not in a slant form. That point where the tangent line meets the curve is called the slope of that curve at that point is what? Is 0. Meaning that at this point here, my dy dx is equals to 0. Not just for maximum. You know, we say this represents maximum. Even if I have, let's say I have a curve like this. If I have a curve like this, at this point here, where this curve changes direction from decreasing to increasing, that point is what? The slope of that point is 0. Meaning that when it differentiates the function of this curve, you have to set it to be 0. So at the turning points of every curve, dy dx must be equals to 0. That is the first condition you should take note of. We call that the necessary condition in the turning point of a curve. There are 2 conditions you must take note of. Number 1 is called the necessary condition. Number 2 is called the sufficient condition. Now, when you hear the word necessary condition, it means that at the turning point of every curve, dy dx must be equals to 0. That's called the turning point. That's called the necessary condition. Then sufficient condition will not tell us the nature of that curve, whether it is minimum, whether it is maximum, whether it has a point called point of what? Inflection. So there are 2 types of turning point of a curve. We have the maximum and the what? Minimum. But don't forget that both the maximum and the minimum, at their turning point, dy dx must be equals to 0. And we call this condition the necessary condition. Okay, now let's move on. Please, if you are following me, indicate in the comment section. If you are following, indicate in the comment section. If you are following. If you understand what I just said now, indicate it in the comment section. Let's proceed. Now we have defined the concept turning point. The turning point is a point in the curve where the curve changes direction from increasing to decreasing, or from decreasing to what? To increasing. And we say we have 2 types of turning points. We have the minimum turning point. Number 2, we have the maximum turning point. The maximum turning point. Then sometimes there's a point called the point of inflection. It's not really a turning point, but point of inflection. I'm going to explain that again for us to understand. I think I've already explained that before. If I have a curve of this kind, here I have a maximum point, I have a minimum point. The point whereby this curve here changes curvature, changes direction, meaning the point where it's deviates from, it moved from maximum to minimum, is called the point of what? Inflection. Point of inflection. So here I have A, I have B, I have C. A is the maximum point, B is the point of inflection, C is the minimum point. Okay, but the major 2 turning points of a curve are this, minimum and maximum. Some materials call these 3 stationary points. Stationary points, okay? We call them stationary what? Points. Okay, are you there, somebody? But the major 2 turning points we are referring to is the minimum and maximum. The point where the curve changes direction from increasing to decreasing is called the minimum and the maximum, which is called the turning point of a curve. Then point of inflection is a point where the curve changes curvature. Curvature. All right? Changes curvature. It's called the point of inflection. All right? That is that. Now let's see. We say we have 2 conditions to determine the turning point of a curve. we have two conditions to determine the turning point of a curve. Number one, we have what we call the necessary condition. The necessary condition. The necessary condition. Okay, the necessary condition must be met before we can say that a curve, okay, has minimum and what, or maximum, or a point of inflection. We must have to meet this. And this condition states that at the turning point of a curve, the turning point of a curve, the y dx must be equals to what? 0. The y dx must be equals to 0. This is called the necessary, the most important condition. The first condition you must have to take note of, observed, before you can classify a curve into minimum or maximum turning points. Or you can also classify, you can also tell if a curve has a point of inflection. Now, the second condition is called the sufficient condition. The sufficient condition. The sufficient condition. The sufficient condition. What does this condition say? The condition is saying that, sufficient condition says that when second derivative, the 2y over the x squared is greater than 0, okay, we have a minimum turning point. Minimum turning point. Either when the 2y over the x squared is less than 0, we have a maximum turning point. Sufficient condition means that I have to further differentiate with the second derivative function, meaning when the 2y over the x squared is greater than 0, we have a minimum turning point of a curve. Then when the 2y the x squared is less than 0, we have the maximum turning point. But whenever the 2y over the x squared is equals to 0, we have what we call the point of inflection. Point of inflection. Please take note of this. Point of what? Inflection. But the major one we're dealing with today is minimum and maximum. In my next class, I will focus on points of inflection. Okay, now let's look at the procedures. The procedures in determining the turning point of a curve. The procedures in determining the turning point of a curve. But I want us to remember, take note that differentiation is not just only used to find the y dx. Some of us, all we know about differentiation is that it is used to find the derivative of a function. No, it's also used to determine the turning point of a curve. Okay, whether a curve has a minimum turning point, maximum turning point. There's also used to determine the stationary points, where we also include the point of inflection, right? It has many applications, not just finding the y dx. So now let's look at the procedures used in determining the turning point of a curve. The procedures used in determining the turning point of a curve. All right. Okay, but let's have a recall, yeah? Let's have a recall. We said we have the first condition, which is called the necessary condition. The necessary condition. And we say that under this, that the y, the x must be equals to 0. Number 2, we say we have the sufficient condition. The sufficient condition. Here we say the 2y over the x squared. When it's greater than 0, we have the minimum. Okay, this simply means positive. Whenever this is greater than 0, it means positive. Number greater than 0 are positive numbers, right? But when the 2y over what? The x squared is less than 0, we have the maximum turning point, meaning negative, right? But when the 2y over the x squared is equals to 0, we have the point of inflection, right? Point of inflection. Okay. Please, if you are following me, indicate in the comment section. If you are following, indicate in the comment section. If you are following us, indicate in the comment section. Now, steps. The first step is that we have to carry out what first? The necessary condition. Necessary condition. Carry out the necessary condition, right? By finding the y, the x, right? Number 2 is that we have to set the y, the x equals to 0 and find x. And find what? X. Please take notes and find x. Okay, we carry out necessary condition by finding the y, the x. Then we have to set the y, the x equals to 0 and find x. Okay, then number three is that we substitute x into the original equation. Okay, good. Substitute x into original equation, meaning the main equation of y equals to f of x given. Okay, and find y. Please take note. Then the fourth is we have to determine the stationary point, which is in form of x and y. The stationary points, which is in form of x and y. Then number 5 is we test x in the 2y. We have to test x in the 2y over the x squared. This is the sufficient condition, right? The sufficient condition. Sufficient what? Condition. We have to test x in the 2y, the x squared. Then yeah, we determine after testing for x, we can determine the minimum, the maximum, or we can also determine the point of what? Point of inflection. Okay, please take note of these steps. Please, very important steps. The first step says we determine the necessary condition, right? By finding the y, the x, which is what I said, that at the turning point of every curve, the y, the x is equal to 0. It's called the necessary condition, meaning it is the most important, the first condition that must be carried out. It is on this condition we can be able to determine if a function has minimum or maximum. Then we set the y, the x equals to 0 to find x. All right, so we have to substitute x into original equation to find y. The essence of doing that is to determine the stationary points in form of x and y. All right, so we can determine that. By this will tell us at what point in the Cartesian graph does maximum point located or minimum point located, right? If it's located upward or downward, it's from here. All right, the fifth one says we have to test x in the 2y over the x squared, meaning sufficient condition. We have to put the values, like putting the value of x in the 2y, the x squared. That means I must have differentiated, must have gotten my second derivative function. Then when you do that, you put the value of x. The value of x we got in number 2. We say find x. I have to put back this x in my d2y over the x squared. Okay, then if it is greater than what? 0, it is minimum turning point. If it's less than 0, is what? Maximum turning point. If it's equal to 0, is what? Point of inflection. So it is from this point here, after putting the value of x, we can be able to know if the second derivative is either less than 0 or greater than 0 or equals to what? 0. All right, so these are the steps that you must have to take note of. Please, if you have a question, please send the question in the comment section. If you have any question to ask, please send before I continue. If you have any question to ask, please indicate in the comment section before we proceed. If you have any question to ask, indicate in the comment section. Indicate in the comment section. If you have any question to ask, indicate in the comment section. All right, indicate in the comment section. Indicate in the comment section. If you have any question to ask, indicate in the comment section. Now, let's solve some problems. Let's solve some problems. If you have any question, indicate. But I want us to solve some problem. Okay, but let me see if I can detect some little notes here. I've already defined turning point, a point where a curve changes direction from increasing to decreasing, right? All right, so I also mentioned the types of turning points. Then I also define a tangent line, right? I say it's a straight line that touches a curve at a particular point and has the same gradient as the curve at that point. A tangent line is a straight line that touches a curve at a particular point and has the same gradient as the curve at that point, right? Just trying to recall the things we discussed about, right? So please take note. Now let's solve one or two questions. All right. Please excuse me, let me get to our past question. I'll prefer to get from past question. Okay, look at this question that says that we should find the turning point of the function. Find the turning point, question 1. Find the turning point of the function. Function is f of x equals to 2x cubed minus 3s squared minus 36x plus 10. All right, and determine whether each is a minimum or a maximum. And determine whether each is a minimum or a maximum. Okay, let's look at this question together. All right, the first is that, what will I say is the first? Is to differentiate this. Yeah, we have a cubic function here. A cubic function. All right, that means that whenever we have a cubic function, don't forget that I give us a graph like this, right? It means that there's a tendency of us having a maximum and what? A minimum at the same time. Then also sometime point of inflection. But today, like I said, I will only focus on what? Maximum and minimum. Whenever they say find the turning point, all they are saying is that determine the maximum or the minimum. But when they say determine the stationary point, it means they're also asking you, check if that function has what? Point of what? Inflection. These are two different questions altogether. Okay, let's look at this. F of x equals to 2x cubed minus 3s squared minus 36 plus 10. So the first is to find the y, the x, right? Okay, we said we have to differentiate this, right? And set this to be equal to 0. Or we say let the y, the x equals to 0. This is, what condition is this? This is called the necessary what? Condition. Okay, so it means I will differentiate this, and that will give us 3 times 2. I'm going to use power rule to differentiate. All right, so let's go. So 3 times 2 will give us 6. Here we have 6x squared, right? Minus 2 times 3. 2 times minus 3 is what? Minus 6x. Don't forget. Why do we have squared here? when you multiply 3 by 2, we have 6. The rule says subtract 1 from the power. Please go back to the previous class. Those of you that missed my class on differentiation, I won't be talking about differentiation today. I'm talking about the applications of differentiation. Please take note. So 3 times 2 is 6. The rule says subtract 1, we have squared. Yeah, the power is 2. So 2 times 3 is what? Is 6. So minus 6 rather. Then when you subtract 1 from 2, we have what? 1. This, when you differentiate minus 36x, I'm going to have minus 36, right? Differentiate 10 is what? Is 0. Every constant have a derivative of 0. So when you differentiate, what we do, we set this equals to a 0. That is the first condition. Okay, it means when you differentiate, I have to put the whole of this equals to a 0. So that means here becomes 6x squared minus 6x minus 36 equals to what? 0. Now, in this case, I will factorize. Don't forget that we say that when you set this equal to 0, we have to find x, right? I'm going to factorize to find the value of x. And don't forget, since this is a quadratic function, means I'll have 2 possible values of x. Whenever the highest power of a function is 2, I mean there are 2 possible values of x. If the function has a power of 1, if the highest power is 1, okay, or if the degree of the function is 1, let's say for example, y equals, let me say this, if I have 2x plus 4 equals to 0, definitely the power of x here is 1. It means we have only one possible answer for x, which is 2x equals to what? Minus 4. So x equals to minus 4 over 2, which is what? Minus 2. But for this, because I have squared, it means there are 2 possible values of x. Then let's see what we can do here. If you look at each of these terms here, they have a common factor of 6. So I can say divide 2 by what? By 6. I will divide 2 by 6. I'll divide this by 6, this by 6. Is that clear? Okay, so this can go with this. We have x squared minus x. Then here we have minus 6, all equals to what? 0. Then we can now factorize to find x, right? We factorize this to find x, So by the time we factorize to find x, how do we factorize? We multiply the first term by the last term. The first term is s squared. Here we have minus 6. So we have s squared times minus 6 is minus 6 s squared. Okay, we want to think out 2 numbers. Now when you multiply them, the result will be minus 6s squared. But when you add or subtract, we're going to have minus x, right? Minus x. Let's think out 2 numbers. Definitely it should be minus 3x and plus x plus 2x, rather, plus 2x. Let's verify and see. Minus 3x times plus 2x is minus 6s squared. But minus 3x plus 2x is what? Minus x. So that means these 2 numbers will replace what? Will replace minus x, right? These 2 numbers here, the factors that we use to replace minus x. And that will give us what? We have s squared minus 3x plus 2x minus 6 all equals to what? 0. So between these 2 terms here, x is common. I will factor out x. When you divide x squared by x, we have x, right? Divide minus 3x by this x, we have minus 3. Okay, plus between these 2 terms, what is common is 2. 2 is common. So if I'm to divide, since 2 is common, I'll divide this 2x by 2, we have x. Then we divide minus 6 by 2, we have minus 3, all equals to a 0. I've taught us here before that any value you have in this first bracket must reappear here. Okay, must reappear. Okay, so just take note of that. Now the next is to find the value of x. We have to check. There's a plus sign here that separates this term with this term. And what is common between this term is x minus 3. So I can bring out x minus 3 as a common factor. If x minus 3 is common, I will divide the whole of this, right, with x minus 3. It means what will remain is what is x. Is that not? Hope you are following. So let's watch. So here we have x. So we divide this. Here we have, okay, in brackets, there will be x. Then when you divide the whole of this with x minus 3, this we cancel this, right? Here we have plus what here? Plus 2. All equals to what here? 0. Or we can just say bring down this, we have x minus 3, which is this. Then we have x plus 2, which is this, then equals to what? 0. Therefore, we can say that x minus 3 is equals to 0. Or x minus x plus 2 is equals to 0. Therefore, x is equals to 3 or x is equals to what? Minus 2. That is not all. The question says, find the turning point of the function. Please, I hope you guys are following. Please, if you are not following, indicate in the comment section. Please, if you are not following, indicate in the comment section. If you are not following, indicate in the comment section. If you are not following, indicate now in the comment section. If you are not following, indicate. I want to believe that we are all following, right? Please indicate in the comment section if you are not following. Indicate in the comment section if you are not following. Okay. All right, let's finish up this. We're almost done. Now we have gotten the values of x. We have x equals to 3 and x equals to minus 2. One of these x here can either be minimum value of x or maximum value of x, but we don't know yet until we proceed to the sufficient condition. All right, now let's see. The first thing we need to do is to bring out the stationary points. The stationary points, which I said is in form of x comma what? Y. Stationary point. I have two values of x here. I will say when x equals to 3, what will be the value of y? Our f of x is given as this, right? So what we do here is to substitute the value of x equals to 3 in this function here. F of x represents y, right? So here, y becomes, here we have 2 times 3 all squared, or to the power of 3, right? Minus 3 times 3 squared, minus 36 times 3 plus 10. Let's see what will be the value of x here. Okay, here we have as y equals to 54 minus, this is 9. 9 times 3 is 27 minus 27. Here we have minus 36 times 3 is minus 108, then plus 10. Let's add up this. We're going to have 54 minus 27 minus 108 plus 10. Here we have minus 71. Y equals to minus 71. All right, minus 71. Okay, so our first stationary point, okay, so here we have when the stationary point, the first stationary point, right, will be When x is what? X is 3. Y is what? What's the y? Minus 71, right? Okay. So the next is when x is equals to, the second value of x is minus 2. Minus 2. So the value of y becomes the same thing we did, that will be repeated for that of x equals to minus 2. That means 2 times minus 2 to the power of 3 minus 3 times minus 2 to the power of 2 minus 36 times minus 2 plus 10. So let's check this out. Minus 2 to the power of 3 is minus 8. So here we have minus 8 times 2 is minus 16. So y equals to minus 16. Okay, yeah. Minus 2 to the power of 2 is 4. Then 4 times minus 3 is minus 12. Here we have. Here will give us plus 72 plus 10. Okay, let's verify again. Here we have minus 8 times 2 is minus 16. Minus 2 to the power of 2 is 4. 4 times minus 3 is minus 12. Minus 36 times minus 2 is plus 72. Minus times minus is plus, right? Then plus what? 10. So let's add up these values. Minus 16, minus 12, plus 72, plus 10. We have our final answer as y equals to 54. Therefore, the second stationary point, right? Stationary point will be when s is what? Minus 2, y is what? 54. All right, so let's verify. So we have two stationary points. We have this and we have this. So we don't really know which of these will be minimum and what maximum. All right, so we have to apply the sufficient condition. The sufficient condition. We have seen the necessary condition. I hope I can take off this. We have to apply the sufficient condition. Okay. Let's take it from here. For the sufficient condition, we say that second derivative, the 2y, the s squared, must either be greater than what? 0, right? Or less than 0, or equals to 0. So let's find the 2y first. That is the first thing. Let's find the 2y. So what do we do here? We have to recall. Let's recall that our first derivative function, dy dx, don't forget that dy dx it was given as 6x squared, right? Minus 6x minus 36. This was the value we got, right? So to find our second derivative means I have to further differentiate this. That means by the 2y, the s squared. That will give us 2 times 6 is 12x minus what? 6. When differentiate minus 6x, the result is what? Minus 6. So this is my second derivative function. But don't forget the two values of x we have. But recall. Okay, let's see. The first value of x is, recall that x is equals to what? Minus 2. And x is equals to what? Equals to 3. Don't forget, we got our value of x as 3 and what? Minus 2. Okay, let me start with s equals to 3 and x equals to what? Minus 2. Is that not? So what do we do here? Is to put the value of x as 3 into this function. I'll put, so when x equals to 3, let's see, the 2y over what? The s squared will be equals to 12 times 3 minus 6, right? Okay, so we have 12 times 3 is about 36. So here we have 36 minus 6 is 30. And 30 is greater than what? 0. Is that not? So when we put the value of x as 3 in this second derivative, you know, we say that we are getting our first point. The first point is when s is what? 3. Y is what? 71. When s is now -2, y is 54. So either of these 2 points is either minimum or maximum. From the comment section, who can tell me when s is 3, after putting the value of x as 3 in the second derivative function, you know, we got 30. Is 30 greater than 0 or less than 0? 30 is actually greater than what? 0. So whenever your second derivative is greater than 0, what do we say we have? Is it minimum or maximum? Definitely is minimum, right? We say that when second derivative is greater than 0, it means it is a minimum turning point. Therefore, minimum turning point occur at what? At 3, what? -71. Why do we have to choose it? Because it is this 3 that gave us 30 that is greater than 0. But let's verify. What if when x is -2? If x is -2, let me finish off from here. When x equals to -2, let's take what the result will be. Our second derivative, the 2y, the s squared, will be equals to what here? Here we have 12 times -2, then -6. 12 times -2 is -24. -24 -6 is -30. And -30, is it greater than 0 or less than 0? It is less than 0. So when the 2y over the s squared is less than 0, what do we have there? Maximum turning point. So that means that maximum occurred at -2, 54. Please take note of this. Maximum occur at this. So at this point we have the maximum. Here we have what? The minimum. Please take note. Okay, question number 2. Question 2. Question 2. Question 2 says, determine the turning points. Determine the turning points of y equals to -2x to the power of 2 plus 8x plus 3. -2x to the power of 2 plus 8x plus 3. Look at this. This is a quadratic graph. You know, I say that whenever the coefficient of s squared is negative, meaning when a is less than 0, all right, the curve we enclose downward, we curve downward, just like this. This is when a is less than 0. But whenever a is greater than 0, I will have a curve of this kind. When a is greater than 0, meaning when here is positive. If I have a function where the coefficient of s squared is positive, let's say I have positive here, this curve must curve upward. But when it's negative, it must curve downward. So the nature of this function already is telling us that the curve must have to curve downward. And downward simply means I will have a maximum point. The maximum point. But let's say find the turning points. So let's find a turning point, meaning the stationary point of that turning point. Okay, so let's go. So solution to this. Now we understand the steps. I will just differentiate this, right? Divide the x of this will give us what? Minus 4x plus 8. Then I will set the y dx, right, to be equals to what? 0. I will set it equals to 0. When I set this equals to 0, that will give us minus 4x plus 8 equals to what? 0. So what do we have here? We have minus 4x is equals to what? Minus 8. So that implies that x is equals to minus 8 over minus 4, right? The answer becomes what? 2. Are we there? The answer becomes 2. Now we have gotten the value of this as 2. Don't forget the steps I mentioned. The first step says differentiate, which we have done. Then set the y dx, your derivative, equals to 0, which I did here. And when we set this, when we set this, then we look for the value of x. I have to move this 8 to the other side, or we subtract 8 from both sides. And that gives us minus 4 equals to minus 8. Then the next is to find the value of x. And the value of x is 2. Okay. So the next is we have to put the value of this x into this function, right? We have to put x in mention. Let me mention it here to minimize space. Put x into equals to 2 in the original function. Which is y equals to minus 2 times 2 all squared plus 8 times 2 plus 3, right? So y becomes minus 2 times 4 is minus 8. 2 squared is 4. Then 4 times minus 2 is what? Is 8. Then here we have plus 16 plus what? 3. All right. So that should be about, so we have minus 8 plus 16 plus 3 is 11, right? So our y is equals to 11. Therefore, the stationary point is simply when x is equals to what? 2 and y is equals to 11. In this equation, the values of x, if you notice, the power of x is 1. So that means the only possible value of x will just be 1, which is x equals to 2. But when the value of x is 2, that means I will solve using quadratic method, right? Either by factorization or by using the quadratic formula to find the values of x. But in this case, we just solve direct by subtracting 8 from both sides, and that gives us the value of x. So we have only one value of x. Good. Now, this stationary point we have, let's determine if it is minimum or what now? Maximum. Let's determine if it is minimum or maximum. Don't forget that to determine if it's minimum or maximum, we have to undergo the sufficient condition, right? Okay. For the sufficient condition, we say that I have to find a second derivative, or just take this off. Just a finding the second derivative. Let's check this out. So let's go. The 2y over the x squared. It means I will differentiate this further. When you differentiate minus 4x, the answer is definitely minus 4. When you differentiate plus 8, the answer is definitely 0. So the answer is what here? Minus 4. And minus 4, is it less than 0 or greater than 0? Minus 4 is less than 0. So what we have here? We have the maximum turning point. Okay, since the 2y over the x squared is less than 0, we have the maximum turning point at 2,11. At 2,11. We have the maximum turning point at 2,11. Please, if you are following, indicate in the comment section that you are following. Please, if you are following, indicate in the comment section that you are following. If you are following me, indicate in the comment section that you are following. Please indicate in the comment section that you are following. Please, someone said minimum. Why do you say minimum? It is maximum because the second derivative function is less than 0. So we have a maximum turning point. I've always shown you guys that whenever we have a function like this, right, the curve will tend to curve this way. Is that not? So it shows that we have a maximum point here. So on the curve itself, that point is 2, 11, meaning when x is 2, y is 11. Okay, let me try and see if I can show us the nature of the graph. If I have a Cartesian diagram, let's say we have of this kind. Let's say I have here as 1, and here is 2, and I have here as, okay, when y is 11, let's say I have 1, I have point 11 here. Let's say this is 11, from 1 to 11. The point where they meet is somewhere here, right? Okay, so the nature of this graph is of this kind. Is of this kind. Do you understand the concept now? Is of this kind. So this point is called the maximum point, and the value is what? 2, 11. So this is how to sketch the graph. This is how to sketch the graph. All right. So let's proceed. Next question. Next question. Next question. Are we there? The next question says that we should find x. Question 3 says find x such that y equals to x plus 1 over x is, number 1, minimum, number 2, maximum. Question say find x such that y equals to x plus 1 over x is either minimum or maximum. This is very simple. In this case here, we are not going to find the stationary points. We only focus on finding the value of x, the minimum value of x and the maximum value of x. Let's see how we can generate this, okay? Okay, so let's go. We are given the function y equals to x plus 1 over x, which is also same as y equals to x plus x to the power of minus 1. Law of indices, right? The power law of indices, or negative power law of indices. If I have 1 over x, this same as x to the power of 1 minus x minus 1. X to the power of what? Minus 1. If I have this, x to the power of minus 2, this same as 1 over x squared. If I have s minus 1, this is 1 over what? X. If I have x to the power of minus 4, this same as 1 over x to the power of 4. Okay. So this is just that here. Why I have to do it? Because I want to differentiate using power rule of differentiation, right? So let's differentiate. I have to differentiate the y dx, okay, equals to differentiating x will give us 1. Here we have plus. Differentiate x minus s in the power of minus 1. The rule says multiply the power with the coefficient of x. Coefficient of x is plus 1. So minus 1 times plus 1 will give us what? Minus x, right? Then the rule say when you multiply, we have to subtract 1 from the power. So minus 1 will give us minus 2. Then the next is to set, right? Set the y dx equals to 0. Therefore, that will give us 1 minus x squared equals to what? 0. Now we have set our divided x equals to 0. So what do we do to find the value of x? Definitely, since I have squared, there will be two possible values of what? Of x. So what we do here is to subtract 1 from both sides, right? Or I can move this to the other side. Therefore, that will give us our x squared equals to what? 1, right? X squared equals to 1. When you move minus x squared to this side, it becomes plus x squared, then equals to 1. Or you can move this, minus cancel minus. When you move plus 1 across, the sign becomes minus 1. Minus can cancel minus from there. That will give us this, right? Then the next is to find the value of x. I will square root both sides to find x. That will give us x equals to root 1. Therefore, our x equals to plus or minus 1. This is plus or minus root 1. Therefore, x is equals to what? 1, or x is equals to minus 1. I hope we know that anytime we find the root of, where's our duster? The root of the square root of a number, the answer will either be plus or minus. Like, for example, if I'm to find the root of 4, I'm going to have minus 2 or plus 2. So the root of 1 is what? Plus 1 or minus 1. Now we have two possible values of x. And we also find x such that this is minimum or maximum. So let's find which of these value of x is the minimum value of x and the maximum value of what of x. So what we do is to apply the sufficient condition. Okay, it means I have to further differentiate. Okay, finding the 2y over the x squared. So the 2y over the x squared will give us, I'm going to further differentiate this, right? This might be y the x. This is the first derivative. So let's find the second derivative. When you differentiate 1, the answer is 0. All right, so we have 0. When you differentiate this, here we have minus x to the power of minus 2. The power law says I'll multiply the power by the coefficient of this x. So minus 2 times minus 1 will give us plus 2x, all to the power of minus 3. Why do we have plus? Because minus times minus is what? Is plus. So we have plus 2. Then when you subtract 1 from this minus 2, the result is minus 3, the power rule of differentiation. Okay, so this is same as the 2y over the x squared is equals to 2 divided by x to the power of what? 3. Don't forget, this is same as 2 divided by x to the power of 3. All right, so let's check this out. But recall that we have two values of what? Of x. The first value of x is 1. I hope we all know how we got this. This also law of indices. If I have this 2x to the power of minus 1, this is like saying 2 times 1 over x, right? 2 times 1 is 2 over what? X. If I have this, if I have 2x to the power of minus 3, this is same as 2 times x to the power of minus 3, which is same as 2 times 1 over x to the power of 3, which is same as what? 2 over what? S to the power of 3. I hope you all understand how we got this so that you will not be confused. All right, so let's proceed. The first is to check when x equals to minus 1. In this case, I'm not putting my value of x into my original function to find a stationary point. They say, what? Find x such that this is minimum or maximum. All right, I'm not to find the turning point. Question did not say find the turning point. So find the value of x that is minimum or maximum. One of these will either be minimum or maximum. Let's check. What we do is to put the value of that, the first x. Let's try that of 1, right? that of when x equals to 1. Let's see what we're going to generate here. Our d2y over the s squared will be equals to 2 divided by, anywhere I see x, I'll put what? 1. So 1 to the power of 3. So what do we notice? That the 2y over the s squared is equals to 1 to the power of 3 is 1. Divide 2 by 1, we're going to have 2. And 2 is greater than 0. So that means that our x, since after putting x as 1, and we got 2, and 2 is greater than 0. Greater than 0 means what? Minimum. That means my x minimum is equals to what? 1. What they say is that find x such that this is minimum or maximum. Meaning find the minimum value of x and the maximum value of x. That's what they are asking for. So after putting the value of the first x as 1, we realize that the result is 2, and 2 is greater than 0. When your second derivative is greater than 0, what do we say we have there? We have the minimum. So the minimum value of x is when x is equals to what? 1. So let's try when x is equals to the second value of x is minus 1. Let's check this out. That will give us the 2y over the s squared is equals to the same 2 divided by, okay, our x here is, the power of x here is 3, so we have minus 1 to the power of 3, and that will give us 2 divided by minus 1. Minus 1 to the power of 3 is same as minus 1. Whenever we raise a negative number to an odd number, right, the result remains negative. So 3 is odd. The result remains negative. So when you divide 2 by negative 1, that will give us minus 2, right? So that means our second derivative, the square y over the s squared. Some use the word squared. You can either say the square y or the 2y. They are all the same. Okay, is equals to minus 2. And minus 2 is less than what? 0. So what does that imply? It implies that x maximum is equals to minus 1. X maximum is equals to minus 1. So take note of that. X maximum is equals to minus 1. Now, okay, someone is asking, so I thought I would substitute the value of x. I explained this. The reason why I did not substitute my value of x in this original equation is that we are not asked to find a turning point of a curve. What we are asked to find is the value of x so that this function is either minimum or maximum. So I don't need to put back the value of x. The only time I will put back the value of x is when we are asked to find the turning point of the curve. Are you there now? I hope I've answered your question. Okay, so let's look at other question. Let's look at other question. Like I said, for today's class, our emphasis will just be on minimum and maximum. All right, so that in my next class, I will focus only on the point of inflection. So the next is we're asked to determine the turning point, determine the turning point, turning points of y equals to x squared. Just x squared. The turning point, y equals to x squared. Solution to this, we already know the first condition, which is called the necessary condition. So we have to differentiate the y dx, which is 2x, right? Okay, the y dx equals to 2x. All right, so the next is to set, we set the y dx equals to 0. In this case, I have to set equals to 0, right, to find x. In this case, I have to find the stationary point now, because we are asked to find the turning point of this curve. This is a curve, all right? Okay, so when we set this equals to 0, that means 2x is equals to 0. So what do we do here? To find the value of x, we divide both sides by 2, right? By 2. So here we're going to have here, therefore x is equals to, okay, let me maximize my space. Sorry. Yeah, x is equals to 0. So what we do here is to put back. We have to put back. We say put x equals to 0 in the equation in f of x. That will give us our y equals to let's check this out. This will give us y equals to, here we have 0 all squared, right? I'm putting back my x into this function. So y equals 0 squared. 0 squared is still 0. Therefore, the stationary point will definitely give us, let's see this, we give us 0, 0, because the value of x is 0, y is 0. Now, the next is to determine whether we have a minimum or a maximum turning point. It means I have to proceed to the sufficient condition. I have to finding the second derivative, which is the 2y over the x squared, right? So when we find that, it means I will differentiate this further. Therefore, the 2y over what? The x squared is equals to 2. 2, is it greater than 0 or less than 0? 2 is greater than 0. So since the second derivative is greater than what? 0, we have a minimum turning point. We have a minimum turning point at what point? At 0, 0. Very important. At 0, 0. Since second derivative of this function, when we differentiate it further, we have 2. And 2 is greater than 0. It means we have a minimum turning point. At what point? At 0, 0. I hope this is clear. Okay, let's differentiate. Let's see one example. All right, so the next question, then I'll be rounding up with this topic. The next question, then I'll be rounding up with this topic. Please, if you are following, indicate that you are following in the comment section. Please indicate, please. Indicate. If you are following, indicate in the comment section. Let's look at this question. Question says, Find all the stationary points, or find the turning point rather. Find the turning points of this function. Find the turning point of the function. The function, we are given y equals to x cubed minus 3x squared minus 9x plus 5 plus 5. I hope we have not solved this particular question before now. Okay, we have not. Okay, so let's see, how do we find the turning point of this function? The first thing we need to do, we all know now, is to differentiate, which is the necessary condition, right? We have to differentiate, divide the x, okay? Or we can start by saying at the turning point of a curve that divide the x must be equal to 0, right? So if this is true, that means I will differentiate this to give us 3x squared divide the x equals to 3x squared minus 6x minus 9 all equals to 0. You know, when you differentiate minus 9x, we have minus 9. When we differentiate 5, we have 0. So no need of adding it here. All right. So we have seen that we have this. So the next is to divide 2 by what? By 3. I can divide 2 by 3. That will give us divided by 3, divided by 3, divided by 3. The reason why I'm dividing 2 by 3 is to have a simplified function in order to enable me factorize either. Although I can factorize this way, but since each of these terms have a common factor of 3, so I can divide 2 by that common factor. But if they don't have a common factor, you can just factorize either. Not all the time you divide by 3 or by 6 or by any number. I'm not dividing by 3 because the first number is 3. No, because the common factor here is what is 3. I can generate 3 from here. I can generate 3 from here. I can generate 3 from here. So that is a common factor of 3. So I can simplify, I can reduce this function to a lighter function by dividing 2 by 3. So if I'm to do that, this will give us s squared, right? Minus what here? Minus 2x, then minus 3, all equals to what? 0. Are we there? Okay, so let's move on. The next is to see if we can factorize this. Let's factorize the function or the expression. Factorize. Let's see. Multiply the first term with the last term. That will give us minus 3x squared, right? Okay. Let's think of two numbers that when you multiply them, that will give you minus 3x squared. But when you add or subtract, that will give us minus 2x. Minus 2x. So let's check this out. We're going to have it as minus 3x plus 1 or plus x, right? Plus x. Let's verify and see. Minus 3x times x plus x is minus 3x squared. Minus 3x plus x is minus 2x, right? I say think of two numbers that when you multiply them, the result will be this. But when you add or you subtract, the result will be the center term here. Either. So we have seen that we can actually work with these two. Minus 3x times plus x is minus 3x squared. Minus 3x plus x is minus 2x squared. So these two numbers, we actually replace minus 2x squared in this function. And that will give us x squared. So I will replace them here as minus 3x plus what? X minus 3, all equals to what? 0. Are we there? So what is common here is actually x. So here we have x minus 3. Then we have plus What is common here is actually 1. We have x minus 3 equals to 0. Are we there? Okay. Yeah, we are factorizing. Okay, this is what we have here. So, okay, then this will give us x minus 3 and x plus 1. Don't forget, all equals to 0. So from here, we can say that by the time we set this equals to 0, it means my x is equals to 3. Or when you set this equals to 0, I'll move 1. It means that the value of x is also equals to minus 1. Are we there? If I have x minus 3 equals to 0, it means x equals to 3, which is this, right? If I have x plus 1 equals to 0, it means x equals to minus 1, which is this, right? Okay. So we have been able to get the two values of x, but we don't know which of these value of x will give us our maximum or minimum, right? So the next is to find the stationary point. The stationary point, right? Okay. So we say when x equals to 3, let's start with this. I will find the value of y, the corresponding value of y when x is 3, by putting the value of x as 3 into this function. Don't forget that the reason why I'm putting my x in this function is because I'm looking for the turning point. Is that not? So let's find the stationary point at which a curve can either be maximum or what, or minimum. All right, so when x is equals to 3, it means that our y becomes 3 to the power of 3 minus 3 times 3 squared minus 9 times 3 plus 5, right? Plus 5. Please, I hope you guys are following. Please, if you are following, indicate that you are following. Indicate that you are following, because I will soon be rounding up with this class. So let's check what we have here. This will give us, this is y equals to 27. 3 squared is 9 minus 27. Here will also give us minus 27, right? Then plus 5. So let's check this out. 9 times 3, okay? So we have here as 27. This is already off. So the next should be minus 27 plus 5 give us minus 22. So y is minus 22. Then our stationary point, the first stationary point is when s is 3, y is minus 22. Then the next one is when x is equals to minus 1, right? Minus 1. Let's check what will be the value of y. The corresponding value of y becomes y equals to minus 1 to the power of 3 minus 3 times minus 1 to the power of 2 minus 9 times minus 1 plus 5. So let's check what we have there. Here we have minus 1. Minus 1 to the power of 2 is 1. Then 1 times minus 3 is minus 3. Here we have plus 9. Minus 9 times minus 1 is plus 9 plus 5, right? Plus 5. So we're going to have minus 4 plus 9, okay, plus 5. This will give us equals to 10. So our stationary point is when s is minus 1, y is 10. That's the second stationary point. But we don't know which of these is either minimum or maximum. So what we do is we have to finding the second derivative, which is the 2y over dx squared. Okay, let's check this out. It means I will now further differentiate. I will further differentiate this. You know, we differentiated this to give us this. Just say recall that the y, the what? The x is 3s squared, right? 3s squared minus 6x minus 9. Is that clear? 3x squared minus 6x minus 9. When we differentiated this, we got 3x squared minus 6x plus 9. So that is what I just recalled. Now the next is to find the second derivative where we have the sufficient condition, which will enable us to determine if we have a maximum turning point or a minimum turning point. At what stationary point do we have maximum and minimum? That is where the sufficient condition comes in, right? So let's move on. So let's go. Let's finish up here. I hope you guys are following. Okay. So let's go. That will give us here. Let's differentiate and see our second derivative function, the 2y, the s squared, will be 2 times 3 will give us 6x minus 6. That is our second derivative function. Okay, so we have to say when the first value of x we add is s as 3. So when x equals to 3, let's see what the nature of this. So that will give us the 2y over the s squared equals to 6 times 3 minus what? 6. All right. So 6 times 3 is about 18. Okay. 18 minus 3 minus 6 rather is about 12, right? 12. Okay. So we have 12, and 12 is actually greater than what? 0. 12 is greater than 0. Please, I hope you guys are following. Please, if you are following, indicate in the comment section that you are following. Please indicate that you are following. Indicate that you are following. Okay. I hope you are aware that 12 is greater than 0. So if since the second derivative, which is the 2y, the s squared, is greater than 0, we have the minimum turning point at what point? At when s is equals to 3, y is what? Minus 22. That means this stationary point here is for minimum, right? It's for minimum. Okay, this is for minimum because our second derivative is greater than 0. So let's verify when x is now equals to, when x is equals to minus 1. Let's verify minus 1. Okay, so let's verify what we have there. Our second derivative, the 2y, the s squared, is equals to, I will put the value here, right, as 6 times minus 1 minus 6. So this will give us minus 6 minus 6, which is minus 12, right? So since the 2y over the s squared is less than what? 0. Therefore, we have the maximum turning point at when x is minus 1, comma what? This is my maximum turning point, right? Maximum minus 1, comma 10. Okay, I think I'm going to stop here. I will just drop an assignment for you guys to solve an attempt. I will drop an assignment for you guys to solve an attempt. Please ensure you solve this assignment I'm dropping, or classwork. I hope it is clear, right? So let's look at this together. Class exercise. Class exercise. The first question says that we should find a turning point. Find a turning point of the following function: y equals minus 3x squared plus 12x minus 5 over 2. Y equals to x squared minus 10x plus 16. Number 3. All right, let me get some question. More question. That's y equals to x cubed minus 6x squared plus 9x plus 4. And the third question. Number 4, explain the two conditions for turning points. Of a curve. Number 5, give the steps for finding turning point of a curve. So these are the assignments or the class exercise. You can just attempt, find the turning point of this curve. Y equals minus 3x squared plus 12x minus 5. Number 2 is y equals to x squared minus 10x plus 16. Number 3 is y equals to x cubed minus 6x squared plus 9x plus 4. Then the fourth one says explain the two conditions for turning point of a curve. Then the fifth says give the steps for finding the turning point of a curve. Then the last question, determine the turning point of this curve. Y equals to x cubed. Y equals to x cubed. Yes, y equals to x cubed. I guess I'm going to stop here. Y equals to x cubed. Please attempt this question. All right. This will be the first question I will solve in my next class on that point of inflection and all that. Okay, so these are your assignments. So I will be ending my class now. So any other time we meet, probably tomorrow, I might be coming online to teach maybe physics this time around. All right. In physics, we will be looking at electromagnetic induction in physics. All right. So that might be the next topic in physics. We are really gone far. We have really gone far in physics. Okay, we have gone far in physics, but I will see how I can do some revisions in some major topics in your physics. So see you guys in my next class. Ensure you go through the notes and make sure you drop your assignments, drop your answer in the comment section. Please. Once you are done solving, drop your answers in the comment section. Thank you guys. See you guys tomorrow.